You know that feeling when you finally decide to upgrade your lab bench and you snag a budget overhead stirrer that looks promising on the website, only to discover a week later that the motor sputters, the speed drops the moment you add a viscous sample, and you end up spending even more time troubleshooting than actually mixing? That's the exact regret a lot of chemists and biotech researchers talk about in forums, and it's why I spent a solid morning digging through product manuals, comparing motor generations, and even watching a few unboxing videos before I pressed record. Link is in the description if you want to check the product details on Amazon. The Heidolph HEI-Torque Precision 200 is positioned as a higher-end option that promises constant speed, torque monitoring, and a quiet motor. So the question is, does it actually feel like a smarter buy, or is it just another pricey piece of equipment that looks good on paper? First off, let's talk about the problem most of us face when we need an overhead stirrer. You have a reaction that needs to be kept homogeneous for hours, maybe a polymerization that gets thick quickly, or a cell culture that's sensitive to shear. The cheap units you see for under a few $100s often use a simple brushed motor and a basic speed dial. They might be fine for water-based solutions, but the moment the viscosity climbs, the speed drops, and you end up with dead zones in the flask. That's not just inefficient, it can actually affect yield or cell viability. The HEI-Torque claims a newest motor generation for maximum power at minimum noise level and a digital readout that shows torque trends. Those sound like the kind of things that keep a reaction under control, especially when you're watching a graph on your laptop and need that data to know when a polymer starts to gel. The way Heidolph built this model into a lab environment is pretty thoughtful. The unit sits on a sturdy base that measures 86 millimeters wide, 273 millimeters tall, and 241 millimeters deep, which means it doesn't dominate the bench, but still feels anchored. The motor sits in a sealed housing, and the whole thing runs at 115V, 120W. When you plug it in, the first thing you notice is the almost silent start, nothing like the whine you get from older stirrers that can drown out conversation. The slide touch panel on the front is where you power it up, set the speed, and start a safe stop. That safe start/stop is more than a convenience. It prevents the magnetic drive from slamming into the beaker if you accidentally hit the wrong button, which can happen when you're juggling pipettes and a laptop. Now, let's walk through a real-world use case. Imagine you're doing a 5-liter batch polymerization in a glass reactor. You attach a magnetic stir bar, set the stirrer to 300 revolutions per minute, and start the reaction. As the monomer begins to polymerize, the mixture thickens. With a standard stirrer, you'd see the RPM drop. The magnetic bar might even start to wobble, and you'd have to manually adjust the speed or swap out the stir bar. With the HEI-Torque, the digital 2.4-inch display shows you a torque value that climbs in real time. When it hits a preset threshold, you can note that the viscosity has reached a certain point, or you can let the software log the trend for later analysis. The constant speed under changing loads means the magnetic bar stays centered, so you avoid dead zones, and you keep the reaction truly homogeneous. That torque monitoring is the real differentiator here. If you're in a quality control environment where you need to document every step, having a numeric readout of torque gives you an extra data point. It's not just a nice-to-have, it can be the basis for a batch record. I've seen labs integrate that readout into their LabVIEW dashboards, and the data line up nicely with temperature and pressure logs. For a researcher who needs to publish reproducible methods, that traceability can be worth the extra $300 to $400 you pay compared to a basic stirrer. Who should definitely consider this unit? First, anyone who works with medium to high viscosity liquids. Think polymer chemists, formulation scientists, and biotech labs that handle cell suspensions or viscous media. Second, labs that run long-duration reactions where you can't afford to stop and tweak the stir rate every hour. Third, anyone who values a quiet workspace. The low-noise motor makes it easier to have a conversation or listen to a phone call without shouting over a humming machine. Who might skip it? If your work is limited to low-viscosity aqueous solutions, like routine buffer mixing or quick dissolutions, a cheaper magnetic stirrer will do the job just fine and save you a decent chunk of budget. Also, if you're setting up a small teaching lab where the equipment gets moved around a lot, the HEI-Torque space, while solid, is a bit heavier than the portable tabletop models you see in undergraduate labs. You'll need a bench that can support its weight, and that could be a logistical hurdle for some institutions. Let's talk about the practical strengths beyond the